Hello, my name is Joshua Gavi. I welcome you to electrochemistry. And today we are going to start with rechargeable cells. We are going to look at rechargeable cells. What are rechargeable cells? What are rechargeable cells? Rechargeable cells are cells which can be recharged once they are discharged by forcing electricity backwards in the cell to restore the reactants. For example, lead acid used in car batteries, which contains 3 or 6 lead acid cells connected in parallel. So we are saying that rechargeable cells, these are cells that can be recharged once they have been discharged. And how do they do this? They do this by forcing electricity moving in the cell backwards, and this restores the reactants. We have given an example of the lead acid cells used in the car battery. Now, always when electricity is coming out, it comes out from this side and going the other side. Now, when we are charging, now we force the electricity to go in the opposite direction. Now, when electricity is going in the opposite direction, it is going to force the restoration of the reactants. It's going to force the restoration of the reactants, and after restoration of the reactants, now the cell can be used again. Explain what occurs during recharging and discharging of a car battery. Explain what occurs during recharging and discharging of a car battery. When recharging, an external voltage excess to the normal voltage is applied to the battery in a reverse direction. That is, when we are recharging the battery, an external voltage, which is the excess of the normal voltage, is applied to the battery in the opposite or reverse direction. For example, here, when you look here, our electrons will move in that direction and electricity goes out. That is during discharging. But in the charging, we shall force the voltage to go in the opposite direction into the battery. And this voltage is above the normal voltage, which always goes out of the normal cell or battery. So we shall force the voltage to go in the opposite direction into the cell, and this is going to cause the battery to charge. The electrode reaction are reversed to restore the free ions which can conduct electricity. So, because we are passing the voltage in opposite direction, and the voltage which is being passed is excess of the normal voltage, which is always passing through the battery, this one will cause the reverse of what happened, and we are going to restore the free ions back into the solution. And during the process of discharging, we always form lead sulfate here on the poles. Lead sulfate is formed. Now, when we pass over the voltage in opposite direction, it is going to release this lead sulfate to dissolve into the solution, and we produce the free ions that can conduct electricity. On discharging, the lead acid cell has lead 2 sulfate, which is a white powder and water accumulating. So when we are discharging, what happens? This lead will dissolve into the solution, and when it dissolves into the solution, it reacts with the sulfate to form lead 2 sulfate, and that lead 2 sulfate always accumulates on the electrodes. Now, that is during the discharging, and it forms what we are calling lead 2 sulfate, which is a white precipitate. And then also there is formation of water. That is when we are carrying out the discharge. And you will see that our electrons flow in this direction. They go up the other side, and then they come this side. At the anode, the lead electrode dissolves slowly, forming lead 2 ions. Now here we have our anode. At this anode, during the discharge, this electrode is made up of lead. It dissolves slowly and it produces lead 2 ions. Now we have our lead ions here, and there is sulfuric acid which is in the solution. The lead 2 ions will dissolve in the solution, and then it will react with the sulfate ions to form lead 2 sulfate, and we shall have hydrogen ions and 2 electrons which are released. Now when this one dissolves in the solution, it releases electrons, and those electrons are carried in that direction, then they will go to the other side of the cathode. Now we have released the lead 2 ions in the solution. Now the lead 2 ions which are released in the solution are going to react with the sulfate. When they react with the sulfate, there will be a release of hydrogen ions. And the 2 electrons that were released here have been taken to the cathode through the wires. Now, at our cathode here, the lead 2 oxide reacts with hydrogen ions from sulfuric acid, forming lead 2 ions. So what is happening here? The lead 2 ion oxide is going to dissolve also to form lead 2 ions, and it will also react with hydrogen, which is coming from the sulfuric acid, to form water. And then the lead 2 ions, which have dissolved into the solution, will react with the sulfate ions, and they will end up forming lead 2 sulfate, which is a white precipitate or white solid that is going to accumulate on the electrodes. So here we have our lead 2 oxide. It will dissolve into sulfuric acid and then reacts with the sulfate and hydrogen ions. We shall produce lead 2 sulfate and water, and there will be a need of the 2 electrons. And these 2 electrons, they are coming from this anode. These are the 2 electrons that were released by our lead when it dissolved into the solution. Now, these lead 2 ions are the ones that are provided to lead 2 oxide to form lead 2 ions. The lead 2 ions, these ones react instantly with the sulfate ions, forming lead 2 sulfate. So we are seeing that at the anode, the lead in the electrode dissolves into the solution to form lead 2 ions, which react with the sulfates to form lead 2 sulfate. And we have also seen that it gives off 2 electrons, which will move into the wire and go to the cathode. Now at the cathode, these lead electrons are going to find layer lead 2 oxide. They will hand over the electrons, and then lead 2 oxide will be reduced to lead 2 ions, which will react with sulfate, and they will end up forming lead 2 sulfate. So, as the battery discharges, lead in the anode and lead dioxide plate, that is our cathode, they are depleted, meaning that they go on reducing, and the concentration of sulfuric acid goes on decreasing. We are seeing that when these ones are released into the solution, lead ions are released into the solution, they end up reacting with the sulfate ions. And when they react with the sulfate ions, sulfuric acid breaks, dissociates more. And the more it dissociates, the more the sulfate ions are removed. And when we remove more sulfate ions, that means that sulfuric acid dissociates more. And that means that the concentration of the sulfuric acid goes on decreasing. Meanwhile, as also our electrodes are being depleted. Study the diagram below showing electrolysis of acidified water. Study the diagram below showing electrolysis of acidified water. So we have our diagram here. We have J and K, they are platinum rods. We have a solution, which is our electrolyte, which they are saying it is acidified water. We have a gas B and gas A, and we have our mediameter connected to the cells or battery by a wire, and here we have a switch. Name gas A and B. They want us to name the gas A here and gas B. What do you think is gas A and what is gas B? Here, our electrolyte is an acidified water, and we have platinum electrodes. So the gas A is going to be hydrogen, and the gas B is going to be oxygen. What conclusion can you draw about the composition of water? What conclusion can you draw about the composition of water? Water is composed of more hydrogen, twice as much as oxygen. We know that the formula for water is H2O, meaning that it has two atoms of hydrogen and one atom of oxygen. Write an equation for the reaction at J and K. Write an equation for the reaction at J and K. What reaction takes place at this electrode here? And what reaction takes place at this electrode here? You can pause the video and then try to work it out. At electrode J, we say that the hydroxyl ions are attracted towards this electrode, and when they are attracted there, they are discharged, and there is formation of oxygen gas and water, and 4 electrons are released. Those electrons will go through here, and when you go at K, hydrogen ions are attracted towards electrode A, and when they reach there, they are discharged. They take up the 2 electrons and they end up forming hydrogen gas, which is collected in this vessel here. If dilute sulfuric acid was replaced with dilute copper 2 sulfate, state and explain what would be observed at K. In the beginning, we were using sulfuric acid dilute as our electrolyte. Now it has been replaced with dilute copper 2 sulfate. So they are asking us to state what we are going to observe and explain what would be observed. What are we going to observe when we replace dilute sulfuric acid as an electrolyte with dilute copper 2 sulfate? One, we shall see a brown coating forms. There will be a brown coating forming. Brown coating will be formed. Now, in the solution, because we have dilute copper 2 sulfate, in the solution we have copper 2 sulfate, and then we have also water. We have water there and copper 2 sulfate. Now, these ones are going to dissociate. Copper 2 sulfate will give us copper 2 ions and sulfate ions, whereas water will give us hydrogen ions and hydroxyl ions. So those are the ions that we have in our solution now. So we already know that now the solution contains water and copper 2 sulfate, which gives us hydrogen ions and copper 2 ions as cations, and hydroxyl ions or hydroxide ions and sulfate ions as anions. So at the cathode, that is K, at the cathode, both hydrogen and copper ions are going to be attracted. So we are seeing that here at the cathode, these two, hydrogen and copper 2 ions are going to be attracted at the cathode here. They will be attracted by the cathode here because they are positively charged and the cathode is negatively charged. But because copper is below hydrogen in the electrochemical cells, the copper 2 ions are the ones that are preferentially going to be discharged. So the copper ions and the hydrogen ions, all of them are going to move to the cathode. But because copper is below hydrogen in the electrochemical cells, copper is going to be discharged and it will form a brown substance that we saw earlier. So copper being discharged, it will pick up 2 electrons that came from the anode and then it becomes copper solid, which is a brown solid. So they're still saying if dilute sulfuric acid was replaced with dilute copper 2 sulfate, state and explain what would be observed at J. Now they want us to explain what will be observed at J. We have looked at what was observed at K. Now they want us to explain what is going to be observed at J. What do you think is going to be observed at J? So we have already said that in our solution, we have copper 2 sulfate and then water. So these ones are going to give us ions, and we are saying that these ions they are giving us, we have the positively charged ions, which includes hydrogen ions and copper 2 ions. We saw that these ones, they are attracted at the cathode. But now we have also the negatively charged ions, which we call anions, the hydroxyl ions and the sulfate ions. Now these ones being negatively charged, they will be attracted to the anode, which is positively charged. Now when both of them are absorbed or attracted to the anode, all of them are not going to be discharged. One of them is the one which is going to be discharged. Which one of those is going to be discharged? Now, at the anode, both sulfate and hydroxyl ions are attracted, but the hydroxyl ions are preferentially discharged since they are lower in the electrochemical cells than sulfate. So when we come, all these ones, the sulfate and hydroxide, they are going to be attracted to the anode here. But when they come here, it is only the hydroxides that are going to be discharged because for them they are below the sulfate in the electrochemical cells. So when the hydroxyls come to the electrode, we are saying that our hydroxyl have moved to the cathode, the anode, and when they reach here, they are going to be discharged. They will lose the electrons, and then we shall form water, and then oxygen gas will be formed. And the oxygen gas is going to collect in this chamber up. And the electrons will be passed over to go to the cathode. Thank you very much for participating in electrochemistry. We have been talking about rechargeable cells. Please don't forget to like, share, and subscribe. Bye-bye.